So right now we're going to be talking about permanent storage. So before we dive in head deep into that, I'll see some of the terms we're going to use. So we're going to talk about bytes and bits. We're going to talk about terabyte, gigabyte, megabyte. Then we're also going to talk about SATA, SATA 2, SATA 3. We're going to talk about SSDs and HDDs. Now, this sounds like a lot, and it is, but don't worry, we'll get through it really, really fast. So, a quick background knowledge: what is byte, what is bit, what is a terabyte, what is a gigabyte. Now, as you can see here, this is basically binary code, and binary code is what the machine runs off of. It's two different values, a plus and a minus, and the system works around that. That's like the basic operational system that every machine runs under. Now each one of these, 0 stands for negative and a plus stands for positive. This stands for no current, this stands for current. And each one of these is called a byte. A bit. Each one of these is called a bit. So 0 would be a bit, 1 would be a bit, 1 would be a bit, 0 would be a bit. And what is a byte now? A byte, bit, byte. A byte is 8 bits. So basically, 1 byte would be 8 bits. 1 million bytes would be 8 million bits. Now, what is a megabyte? A megabyte is a million bytes. What is a gigabyte? A gigabyte is a billion bytes. And what is a terabyte? A terabyte is one step further. It's a bit more. Now that you know the basic about the storage units, how they're calculated, let's dive into saying how this stuff works. So HDD, a hard drive disk, is what it sounds like. It's a disk. So it's a box in that box there's a mechanical drive spinning. There's a magnetic disk spinning really fast, depending on the drive you're getting, at approximately 5,000 RPM. And what there's a little hand which swivels and writes information onto this platter by giving it binary code, so it gives pluses or minuses, and it's good. You can have a lot of data stored like that, but it's not that fast. Now SSDs, contrary to that, they do not have any moving parts, so they have a few advantages over hard drives. One of which is there's no data fragmentation. Now, what is data fragmentation? When you delete something from your hard drive, what happens is there's a little slot in the physical disk which becomes empty. Now, when you're downloading something new, that slot's going to get filled in, and then other slots are going to get filled in. So the data will not all be together. It will be clustered all around. So there'll be a bit there, a bit there, a bit there, a bit there. And the problem with that is it takes longer for the hard drive to actually detect what you're looking for. So that is called data fragmentation, because everything is fragmented, it's spread out, and that slows down the disk. And that's the reason why machines slow down over time. So if you're running a solid-state drive, your machine is less likely to slow down. Additionally, solid-state drives not having any moving parts, when the computer is started up, it will start up much faster. Therefore, that's why it's a good idea to put the operating system onto the solid-state drive. Continuing on from there, what are the different variants they come at? So hard drives come at approximately 250 gigabytes to 4 terabytes. I went ahead and got myself a 2 terabyte hard drive. And then solid state drives are much more expensive because they're just newer technology and much faster. I went ahead and got myself a 240 gigabyte one. And that is good for running the operating system and any other like small programs I need. Putting some of my favorite games on there. You can get hard drives at different speeds. You can get them at 5,400 RPM. Now that is good for mass storage, because the slower the drive, the more reliable it is. But the slower it works, basically, it takes longer to put data onto there. I actually went ahead and got myself a 7,200 RPM drive, which is a mid-range drive. It's a performance one. And then there's the 10,000 RPM ones. And I'm laughing because it's basically a performance drive on steroids, and they're useless because they're super expensive, and you can just get a solid state drive instead. They're not reliable whatsoever, the hard drives which run at 10,000 RPM. Now from there, if we continue on to compatibility. So a few things you consider in compatibility is whether you have enough power to run as many hard drives as you're getting. so you might want to get a power supply which has enough power for everything. Additionally, there's different connectors which connect your hard drive to your motherboard. It's called SATA, and you want to head and get a SATA 3 drive, and that's the latest ones that are out, and they basically run at 6 gigabits. Gigabits, remember, not gigabytes. So you therefore, to find the value in gigabytes, you have to divide 6 gigabits by 8, and then you'll get the value in bytes. So it runs at 6 gigabits per second, and that's the fastest we got right now. Compatibility issues. So when you're getting a hard drives or solid state drives, you want to get the SATA one, and SATA is basically the latest technology we have in data transfer between the hard drive and the motherboard. And SATA 3, you want to get that, and SATA 3 is 6 gigabits per second. So you want to be sure that your motherboard has a SATA 3 slots and that your hard drive has SATA 3 slots. Therefore, you can connect it with the cables, and you can just power it up, and then no problem there. Yeah, that's all about compatibility. So to summarize, you want to get an SSD for your operating system and things that you run most commonly. You want to get a hard drive for mass media storage. You want to be sure that they're SATA 3 because that's the best thing you can get right now. And yeah, if you're getting a hard drive for mass storage, you want to go with the lower RPMs. If you're getting a hard drive for just general stuff, like if your computer is not going to be a server or anything like that, you want to get a 7,200 RPM one. Don't get a 10,000 RPM one. Alright, that'll be all.